Hello, I am a Bullis Student Tutor. Today we will be talking about the derivation and application of the completing the square formula. The completing the square formula allows you to go from standard form to vertex form. I will do a demonstration about how to do this now. The first step would be to divide by a so that the first term has no coefficient. Next, we would use the completing the square formula to isolate the x minus h term. In this case, b over 2a represents h, and b squared over 4a squared plus c over a represents k. It is natural to wonder, why does this formula work, and how does it make sense? We're going to look at this equation in terms of area. First, we'll look at the square. The area of the square would be x times x, making it x squared. The area of this rectangle to the side would be a times x, ax. So that's how we get the equation here at the top left. If we were to split the box ax in half, we would essentially get two rectangles of size a over 2. Let's add that to our x square. As you can see, the lengths of the sides are still x, and the shorter sides are still a over 2. If this were to make a complete square, then the side lengths would be x plus a over 2, all squared, as we see here. However, it is not, so we will need to subtract this area that would complete the square here. Seeing as the sides line up with both of the shorter sides for the rectangles, the area of this square is a over 2 squared, and we will subtract that from the equation. And that is how you get the formula for completing the square. If we look again at my example from earlier, you can see this is the exact process that I used to change the formula from standard form into vertex form. This has been a Bullis Student Tutors video. If you enjoyed this video, please check our channel for more. Thank you for watching.